We have decided to use the proportional resonant controller. This has less steady state error and performs better harmonically when compared to a PI controller. This controller uses two inputs, reference input and a feedback input. It essentially takes the feedback signal and subtracts it from the reference signal in order to generate an error signal. This error signal is then sent to the controller and corrected according to the transfer equation shown below. And the corresponding control signal is outputted from the controller to the pulse width modulator. For the pulse width modulator, we have decided to use unipolar PWM over bipolar PWM. The difference between unipolar and bipolar is that unipolar uses different reference signals for each commutation cell, unlike bipolar. As a result of that, switching harmonics have shifted to twice the switching frequency, which makes it much easier for the passive filter to remove higher frequencies, and therefore passive filters are also much smaller. In open loop control, sinusoidal pulse width modulation is generated using generated sine waves from math.h as a control signal, and in closed loop, the output from the controller was used as the control signal. For grid implementation, two more things were required to be implemented: second order generalized integrator and phase lock loop. The second order generalized integrator, or SOGI, uses the grid voltage and generates two orthogonal voltage signals by introducing a delay of 90 degrees into one of the signals. The phase lock loop takes these orthogonal values and performs a DQ transformation and extracts the grid phase voltage from the Q components in a nutshell. This grid phase will be used later to generate the reference current for the controller. Results and discussions. Testing proves that the software was implemented correctly and was working as designed. On the image to your left, you have four signals which show the gating signals to each of the IGBTs, and on your right, you have the top sinusoidal signal, which is voltage, and your bottom sinusoidal signal, which is current. Hardware-wise, each hardware component has been individually tested and confirmed working. However, optimization problems in the gate driver circuit are needed to be resolved for the inverter to fully operate. Thank you for listening to our presentation.